Greetings and salutations, magical chemists. Today we're going to talk about significant figures, otherwise known as Sig Figs. Sig Figs are what allow you to determine the precision in a given measurement. The rule of thumb for measurements is that you're going to identify the markings on the instrument you're using to measure and then estimate to one more place value. So let's go ahead and try a couple of examples. Before actually making measurements, we're going to go ahead and identify the place value of the markings on each of these instruments. So go ahead and try that, and then when you're ready to check your answers, unpause the video. So the markings on this first graduated cylinder are to the ones place. Remember, even though the numbers written on the graduated cylinder are only to the tens place, you have to actually look at where the markings are. The next graduated cylinder has markings to the tenths place. The first ruler has markings at the ones place, and the second ruler has markings to the tenths place. Okay, now let's measure. Remember, you want to measure to the bottom of the meniscus, the bottom of the curve. And so you're trying to figure out where the heck this falls relative to the markings. Well, I'm going to claim I think it's exactly on the line for 43. But be careful. If I stopped at 43, that's only the ones place, and I have to estimate to one more place value, which means with precision, my measurement would be 43.0. Now, if you disagreed, you thought it was a little above or a little below the line, so you think it's 42.9 or 43.1, you're still right. That last digit is estimated. There's some wiggle room there, but it should be pretty close to my value. All right, if you haven't tried them yet, to go ahead and try making the measurements on these other three things, and when you're ready to check the answers, unpause the video. And there you have it. How did you do? Remember, as long as you always estimate to one more place value past the markings, you will always have very precise measurements. All right, now let's go ahead and take a look at the rules for significant figures, which are useful when we don't actually make the measurements ourselves. We're using someone else's data. Well, the first rule is that if it's not a zero, it's always significant. So non-zero digits are always significant. And if you have what I call sandwich zeros, which are zeros between non-zero digits, I don't care how many there are, sandwiches are delicious, so sandwich zeros are always significant. For instance, the number 102 has 3 sig figs, and the number 1.73005 has 6 sig figs. You might recall that leading zeros are never significant. These are the zeros that are found on the left. So for instance, 0.37 only has 2 sig figs. That first zero is leading and doesn't count. And 0.0001 is only 1 sig fig. All of the zeros at the beginning are considered leading and thus are not significant. Now, zeros that are found on the right, or trailing zeros, are only significant if and only if there is a decimal point anywhere in the number. So the number 100 only has 1 sig fig, but the number 100 point, which looks weird but it's totally a thing, has 3 sig figs. And 0.0100, well, the 2 leading zeros don't count, but the trailing zeros do because of the decimal, so that's 3 sig figs. For scientific notation, all of the numbers found before the times 10 are significant. So 5 times 10 to the 4th only has 1 sig fig, but 1.30 times 10 to the negative 13th, well, that has 3 sig figs. Now, watch out for counting numbers and conversion factors. Counting numbers, like if you're counting people or kittens, if you have 2 people or 5 kittens, that's an exact value. It's not estimated. Same with conversion factors. 12 inches in a foot, that's an exact. There are 12. So those are considered to have an infinite number of sig figs because they are not estimated values. So if you have 3 cats and 1 student, well, those values, if you wanted to write it very precisely, it would be 3.00000 to infinity, as an infinite number of sig figs. All right, now that we've looked over the rules, let's take a moment to review and practice. Hey, look, practice problems, everyone's favorite. So you are going to pause the video here and you're going to try these. And when you are ready to check your answer, unpause the video. So let's check the first column, and then the second column. The last number on the second column was kind of a trick. It depends on if you recognize that as a conversion factor, which it is. That's the speed of light. In which case, since it's a universal constant, we would say it has an infinite number of sig figs. But if you just thought it was a number, then you said 4, you're still good. Now let's take a moment to review the rules for using sig figs in delicious calculations. Luckily, there are only 2 rules that you need to know when you're calculating with sig figs. The first rule has to do with addition and subtraction. In that case, you're going to want to round to the least precise place value. However, in multiplication and division, in that case you want to round to the least precise total number of sig figs. And a quick trick to help you remember that. So addition and subtraction go to place value, which is awesome people, and multiplication division go to total number, which is a memorization technique. So if you remember your awesome people memorization technique, you will always know your sig fig calculation rules. And just a quick reminder, please do not round if you have multiple calculations to do until the very, very end, which yes is annoying, but it's totally a thing. All right, let's try some of those tasty calculations for ourselves. Now, before we actually try these in terms of sig fig rounding, it's important to find out what the calculator would say the correct answer was and go from there. So let's take a brief moment and identify the calculator answer for all 6 problems, and then we are totally going to rock out with the sig figs. Okay, now we have answers, calculator answers. Now we can worry about the sig figs. So the first 3 examples are all addition and subtraction, which means we need to be worrying about the least precise place value. So the trick to figuring out the least precise place value is you need to look at each given number and identify the digit that is furthest to the right that is still significant. So that's what I've underlined here. Next, you need to figure out which one of those underlined digits is the least precise or least specific. That means the one that's going to be further to the right. So that's this one. Since that number has the least precise place value, that place value, 2 numbers after the decimal, must be where we round our final calculated answer to. Don't forget about the rules of rounding. There's a 5 next to that 1, so that is going to bump it up. So our final sig fig rounded answer is 5.42. All right, go ahead and take a look at the next 2 examples, try them, and when you're ready to check your answer, go ahead and unpause the video. So the second example problem needs to be rounded to the 10th place, so the answer is 5.6. The third example problem is one of my favorites. The trick on example number 3 is to recognize that the 0 all the way to the right in 1010 is not significant. Thus, when you're looking for the least precise place value, it is in fact the least precise place value is found on that first number, but it's found in the tens place. Which means, of course, our answer has to be rounded to the tens place. But there's a 6 next to it and that bumps it up. So our sig fig rounded answer is 1010. Which is a little crazy, right? Because we started with 1010 and then we subtracted things. But with the level of precision in that number 1010, subtracting 2.9 and 0.76 is still within that plus or minus error factor. So officially, according to sig figs, we didn't change the number at all. Crazy, but true. All right, let's try examples 4 through 6, which are multiplication and division. 4 and 5 are multiplication and division. So if you recall, the rules for multiplication and division are looking at the least precise total number, which means before you do anything, you have to figure out how many total sig figs are in each of the numbers that you've multiplied or divided. Well, in the 3 numbers being multiplied, the one that has the fewest total number is that very last one, 0.53, only has 2 sig figs. That means that we need to round our calculator answer to a grand total of 2 sig figs. Remember, you keep the first 2 sig figs that you find when you are zooming in from the left, but we still have to watch out for rounding. And although the 7 bumps the 9 up, so it rounds from 6.9 up to 7, it has to be 7.0 to keep the 2 sig figs that we found in our least precise total number. All right, if you haven't tried it yet, go ahead and try this second example here, and then when you're ready to check your answer, unpause the video. In this case, the least total number of sig figs was 3, so our final answer was rounded to 0.626. All right, last one, the fun one. This is when you're combining calculations. We've got subtraction and multiplication. It's okay, we can do this. Now, the first thing you want to do, this is still PEMDAS, so you want to calculate what's in the parentheses, and you're going to pretend that the rest of this doesn't exist, and you're going to look at this as though you were going to stop just with the stuff in parentheses and figure out those sig figs. So when I look at my calculator and I simply subtract these things, I discover I get an answer of 0.499. If I was going to stop here from subtraction, I would have to be looking at place value. And so by place value, I would have to round to 2 numbers after the decimal, which means I would end up with 2 sig figs. Now I'm not going to round because I'm not done. I still have to multiply. Also, funny story, that's not actually the right answer when I checked again with my calculator. I was slightly off. It should have been 19.97, which is important because now I've got 3 numbers to multiply. So I have to look at their total number of sig figs and round my answer based on the least precise total number. And in this case, it was the subtracted value with the least total number. So that means I need to round my final answer to just 2 sig figs. But don't forget about rounding. So I would get an answer of 20, but I need 2 sig figs. So it is 20 point for my final sig fig rounded answer. All right, at the bottom of the page, there are some more practice calculations just for you. So go ahead and try these beautiful things, and when you are ready to check your answers, unpause the video. So here are the calculator answers, and then here are the first 2 sig fig rounded answers. Here are the last 2. And there you have it. Thank you for playing with chemistry and all of the glories of sig figs. Good luck, have fun!